2018 Core 2 question 9. Okay, first part. Show that x equals 2 is a root of the equation of this. Okay, let's first of all make this into equation where it's, so we've got x minus 1 equals 6 over 2x squared minus 5. And to show it's a root, we just need to basically sub in 2 and say that's equal to that. I'm going to take it a step forward. So I mean, the simple marks will be just simply just putting on 2 into there, so that'll be 2 over 2 take away 1 is 1, and 6 over 2 squared is 4, times 2 is 8, 8 take away 5, and showing that 2 is equal to 6 over 3, and it works. That's the simplest way. So you definitely get 1 mark for showing that. I'm going to take it a bit step forward because it's going to help me in the second line here when I need to find the 2 of the roots. It's by expanding that, getting rid of the fractions, so cross multiply. X times 2x squared minus 5 equals 6 upper bracket x minus 1. We got rid of all the fractions by a simple process of cross multiplying. Expand this bracket out, so we get 2x cubed, x times minus 5 is minus 5x, 6 times x is 6x, 6 times minus 1 is minus 6, and then bring everything to one side, in this case the left hand side, 2x cubed minus 5x minus 6x, so I'm taking that to the side, I'm taking that also to the side, minus 6, opposite is plus 6, and that is equal to 7, equal to 0, my bad, and just collect those together, you get 2x cubed minus 11x plus 6 is equal to 0. I'm just going to call that function x, which is 2x cubed minus 11x plus 6. And now if you want to also show that when you put the number 2 in here, due to remainder theorem, this must be equal to 0 if that's an exact factor. So if you put 2 in there, cube it, take away 11, 2 plus 6, 2 cubed is 8, 8 times 2 is 16, minus 22 plus 6, and 16 plus 2 is 22, take away 22 is 0, therefore x minus 2 is a factor. Now, the reason why I did this, because this will just drop nicely to do the second part, which does say use algebraic method to find the other 2 roots of the equation, giving your answer exact form. So that exact form is hinting me that that's going to end up being a quadratic that you can't factorize, and in that case we need to complete the square. So let's just first of all do this process first, which is called the long division process. I'm going to get the factor x minus 2 and do long division by dividing this. Now when we've got this function, we are missing the x squared term. Now if we're missing any term, we must put it in with the 0 coefficient, okay, because it's very important when we're doing long division, we put everything in descending order so we don't miss out any term. So we've got 2x cubed plus 0x squared minus 11x plus 6. Okay, and then we just simply, what do we times x to get 2x squared? So that's going to be 2x cubed, so we get 2x squared. So 2x squared times x is 2x cubed. 2x squared times minus 2 is minus 4x squared. Subtract those. The reason why I subtract those because we have made those the same, so they should disappear as always. And then 0 minus minus 4, that would be positive 4x squared, and just simply bring these down, minus 11x plus 6. Start the process again. What do I times x to get 4x squared? That would be a plus 4x, times it out, 4x times x is 4x squared, 4x times minus 2 is minus 8x, and there's nothing there, so you can just put 0 if you want. Now as always, this first term should disappear, and minus 11 minus minus, which makes it a plus, minus 11 minus minus 8, so it's minus 11 plus 8 will give you minus 3x, and 6 take away nothing is just 6. What do I times x to get minus 3x? That'll here minus 3. Minus 3 times x is minus 3x. Minus 3 times minus 2 is plus 6. And now minus 3 minus minus 3, so that becomes a plus. So minus 3 plus 3 is 0. And 6 take away 6 is 0. So what you end up here is 0, which should be the case. If you have not got 0 there, you've made an error in somewhere over here. Most likely what most kids do is the positive negative, they've subtracted incorrectly somewhere along here. So just double check it or start again and just be a bit more careful, diligent, that you make sure that you're doing this correctly. Okay, but this must be 0 in order for that to be a factor, which we know it is because we've done that in the factor remainder theorem here. Okay, so we know that's the case. So now we can just put f of x would equal x minus 2 and 2x squared plus 4x minus 3. Now we know that x equals 2 is a root. We just need to find the other two possible roots, and looking at it straight away I can tell that this will not factorize. So because it doesn't factorize, I'm just going to use, I mean you could use the quadratic equation if you want. I just prefer to use completing the square. It's the same thing, one's derived from the other. So I'm just going to quickly just put the 2 out there, make that x squared plus 2x close bracket minus 3, and make that equal to 0. Okay, so now I want it, or this part I want to make it equal to 0 so I can solve it. I've took the 2 out, that times that is 2x squared, that's 4x minus 3. And the reason why I've done that, because the coefficient of x squared when you're completing the square must equal 1. So I'm going to quickly just complete the square. So complete the square by putting the x in there, the squared outside, half that, which is just 1. And that squared is 1, so I take that away. This minus 3, I'm just going to plug it to the other side, so that becomes, get rid of that. So that's already on that side. And I'm just going to quickly just take that to the other side too. So what I'll end up with is x plus 1 all squared minus 1 equal to 3 over 2. Okay, and this minus 1, take it to the other side by plussing 1, so I'll end up with x plus 1 squared equals, well, 1.5 plus that is plus 1 is 5 halves. The opposite of squaring is square root. So remember, when you square it, you get plus or minus. Okay, and to find what x is now, simply to find the two other roots, x is just take that 1 to the other side, becomes a minus 1 plus or minus 5 over 2 square root. So you can leave it like that, or you can try and put it as rationalize the denominator, but I'll let you do that. I'm just going to leave this at the moment like that, so I'm quite happy with that. Okay.